Verify del 2u del x del y, which is equal to del 2u del y del x for the function u is equal to tan inverse of x by y. So this is one more example on partial differentiation. Let us, what we have given that u is equal to tan inverse of x by y. For this function, we will try to find out the partial derivative of u with respect to x and y, then partial derivative of u with respect to y and x. So we have to prove that second order partial derivative of u with respect to x and y, and then the partial derivative of second order partial derivative of u with respect to y and x. So differentiating one partially with respect to x, we have del u del x, partial derivative of u with respect to x. And we know that the derivative of tan inverse of x is 1 upon 1 plus x square. So here in place of x, we have x by y. So 1 upon 1 plus x by y whole square. Again, the partial derivative of x by y with respect to x. Now, if we take the LCM of this part, it will become y square plus x square upon y square, and this y square goes to numerator. So 1 into y square will become y square upon y square plus x square. And similarly, what is the derivative of 1 of x upon y with respect to x? So we can take 1 upon y common outside, and derivative of x is nothing but 1. So we have the answer 1 by y. Now, the 1y and this y will cancel. So therefore, del u del x is equal to y upon x square plus y square. So this is the partial derivative of u with respect to x. Now, we want to find out the partial derivative of second order partial derivative with respect to x and y. So let us try to. Now again, differentiating it with respect to y, we have del 2u del y del x, which is written as derivative of partial derivative of y with respect to del partial derivative of u with respect to x, and we have to again differentiate partially with respect to y. So we know that what is the value of del u del x. In the last step we have done, del u del x is nothing but y upon root x square plus y square. So let us just put the value of del u del x. Now here, since numerator and denominator both are functions of y, so we have to apply the division rule. According to division rule, denominator derivative of y with respect to y is 1 minus numerator, which is y, and partial derivative of denominator. So x square is derivative of x square with respect to y is 0, and derivative of y square with respect to y is 2y. Right, so this is what? This is the partial derivative of y upon x square plus y square with respect to y. Now let us simplify it. X square plus y square into 1 is x square plus y square. This is minus y into 2y. This will become minus 2y square. So this is plus y square and this is minus 2y square. So we have x square minus y square upon x square plus y square whole square. This is the partial derivative of u with respect to y and x. Let us try to find out the partial derivative of u with respect to x and y. Differentiating one with respect to y, partially with respect to y, we have del u del y, which is equal to partial derivative of tan inverse of x by y with respect to y. Now, again, we know that what is the derivative of tan inverse of x? It is nothing but 1 upon 1 plus x square. So in place of x here, it is x by y into partial derivative of x by y with respect to y. Now here, what is the derivative of 1 upon y? Because we can take x outside. So derivative of 1 upon y is nothing but minus 1 upon y square. So its value is minus x upon y square. We can write down. This can be again written as y square plus x square, and this upon y square, this y square goes to numerator and it will become like this, into x we can take outside, and derivative of 1 upon y is minus 1 upon y square. So this y square and y square will cancel, and we have the answer minus x upon y square plus x square. Now we want to differentiate del u del y with respect to x. So this is the value of del u del y with respect to uh, uh, partial derivative of u with respect to y. Now we want to find out the partial derivative of u with respect to x and y. So we have partial derivative of del u del y with respect to x, and we know that del u del x in the last step we obtained. It is minus x upon x square plus y square. Again, we use the division rule because numerator and denominator both are functions of x. So let us use the division rule. Denominator derivative of x is 1 minus numerator is x, and derivative of x square plus y square with respect to x is 2x plus 0. So we can only write down 2x. Now let us simplify it. Minus of x square plus y square minus 2x square is, again it is minus 2x square. So this is plus x square. This is minus 2x square. So we have y square minus x square. And if we multiply by the minus sign, we have again x square minus y square upon x square plus y square whole square. So clearly from equation number 2 and 3, we have del 2u del y del x, which is equal to x square minus y square upon x plus y whole square, x square plus y square whole square, which is similar to del 2u del x del y. Hence proved. Thank you.